So this section is all about composite functions and the chain rule. Now, we've been through a bunch of derivative rules up to this point, including the product and the quotient rules that we talked about last time. The chain rule is a rule that we need to take derivatives of functions under very specific circumstances, and those are what are known as composite functions. And all that composite functions really means is that we are dealing with a function that is made up of other functions, but instead of them being added together or subtracted or multiplied or divided, it's like we're putting one function in for the input in another function. So I'm going to give you a couple of examples of functions that are composite functions. Okay. If I had, I don't know, h of x equals the square root of 3x minus 7. Okay, that is a composite function. And the reason that that is a composite function is because I have kind of two things going on. On the inside, if you want to think of it that way, I have this 3x minus 7. And I am putting that into this function on the outside, the square root function. So another way to write this h of x function would be to say that h of x equals g of f of x where f of x equals 3x minus 7 and g of x equals root x. Okay, so I've got these two functions, the 3x minus 7 and the square root of x. Those are the functions that make up my h of x function. And to get them, I have the g of x function, the square root function, that's on the outside, right? I'm taking the square root of the f of x function. I am replacing the x with the 3x minus 7. Okay, that's a composite function. Let me give you one more example of a composite function. And then in the next video, we will take a look at the chain rule and how that applies. So here's another example of a composite function. Let's say this time I have h of x is equal to 3 times 4x squared minus 12 cubed. Okay, so here's a function. And then what I want to start to look at when I'm thinking about, is this a composite function, is there a complete function that is being put into, that is being used as kind of the inside of an outer function? Well, parentheses are a really good sign that this is happening. If there's parentheses with a function stuck inside, that's a good sign that we're dealing with a composite function. So are other grouping symbols, like in this last one, we had a square root, cube root, those types of grouping symbols. Brackets are another good one. So you're kind of on the lookout for those types of symbols. And in this particular instance, we can see on the outside, we have these grouping symbols, the 3 with the parentheses and the part that's being cubed. Inside that set of grouping symbols, we have this 4x squared minus 12. So is this a composite function? Yes, it is. The inside function is the 4x squared minus 12. The outside function, if you want to think of it that way, is 3x cubed, because you can see if we take the 4x squared minus 12 and replace the x in the 3x cubed by that, that's when we get the h of x. So h of x is a composite function. It is made up of g of f of x. Okay. And so in the next video, we will talk about the chain rule and why that applies to composite functions.